Alright, so in this video, again, I'm just going to go through another mechanism here. Typically on a free response exam, for organic chemistry, they're not going to ask you to predict this product here. They're not going to ask you to predict that. However, what they will ask you, what your professor will ask you and will expect you to understand, is that how do you form that product? So what is the reaction mechanism? So how do you make this product right here? And so that's what they expect you to know. They expect you to understand how to write that mechanism. That way you can show how you arrived at this final product. And that's what this video is going to be about. This video is just going to show you how you would write that mechanism, how you would go about that with pushing electrons and things of that nature. So let's go ahead and get started here. So the first thing you have to do, again, as we all already know, first step in these reactions. This is the first step. If you don't do anything on this, don't when you come across a problem like this and you get stuck, don't leave it blank. If anything, at the very least, write out the first step and get some partial credit. And the first step is always 100% of the time, the first step in these acid-base reactions here is going to be protonation. You're going to protonate. So at least just protonate. If you do nothing else, just protonate. So which hydroxyl group are we going to protonate here? And the one that's going to lead us to our final product is this one right here. This is the one we have to protonate, and that's what we're going to do. So I'm going to protonate that hydroxyl group. That hydroxyl, that oxygen is going to pick up a proton, and so we're going to protonate that. So that's where I'm going to start with this one right here. And so there's our protonation. There's our hydronium. And this is actually really, really favorable energetically, because, as I'll show you in a second, so once this leaving group leaves, so that's the next step here, the leaving group leaves, we've formed a really good leaving group. We're going to make water there. I'm sorry about my drawings here. I'm gonna make this a lot clearer for sure. Definitely. So here we go. We're gonna form that carbocation there, right? Okay, so this is really, really nice because we've formed a tertiary carbocation. So not only is it tertiary, but also it's resonance stabilized big time. So that carbocation there is really, really stable. Again, we would prefer to have 4 bonds, but if we're going to have a carbocation, that's the one we want, because it's not only stabilized by these electron donating groups this way here, it's also stabilized by resonance through the benzene ring here and through the benzene ring here. So that carbocation can go in all 3 directions, which is really, really nice. So that, again, that's the situation we want to be in. And for this problem, that's what we want. So moving on to my next slide, I'm going to show you how what the next step is going to be. So again, I'm going to draw this over. So I have this right here. And so now, instead of writing out benzene, just for the sake of time, I'm going to write out pH like this, because that a phenyl group is a benzene ring, and so that just saves us time. And now that you know that carbocation there is resonance stabilized by the benzene groups, or in other words, by the phenyl groups, then I think we're okay. So what happens next here, in order to get us to our final product, is you're going to have a methyl shift. So this methyl group here it doesn't matter which one you pick. I'm just going to, you know what, I'm going to pick this one right here. I'm going to move it right there, just like that. And so we're going to have a methyl shift right there, which is going to leave us with something like this. Now, where did our carbocation go? Our carbocation now, oh, excuse me, I'm so sorry. This was an OH right there. So that was an OH. Now we have our OH right there. All right, so our carbocation is now here, right? Now it's there. So what I did here, where I'm writing my lines here, so actually, you know what, let me erase that. Sorry about that. So what I did here, all I did was move that, there was an OH there, but I moved it on the carbon, I moved it over here next door. I just flipped them. That doesn't matter. We're going to get our same product regardless. I just, I made a mistake there, so I just ended up putting the hydroxyl there in case you're wondering why it's over here instead of over here. All we did is rotate the bonds. So this carbocation here now is resonance stabilized as well through the action of the electron donating effects of that hydroxyl group. So if we want to draw a resonance structure, what we can do is actually, and now I'm going to rotate that back out so how it used to be. So if we do that, we're going to get that. We're going to get something like that. Okay, so that's exactly what we want. So if we draw a resonance structure, again, resonance structure has to be shown with arrows like that. If we draw a resonance structure, we're going to get a positive charge on that oxygen just like that, and that actually leads us to our final product because so you have conjugate base in solution. I'm just going to denote that as A minus because that's our conjugate base. Again, we started with a proton, so I'm just going to use A minus as a base here, and that's going to come in and deprotonate that hydrogen there. Those electrons are going to jump on oxygen, and you're going to get your final product here, which is what, and I'm just going to redraw those rings out so you all can see, which is what we wanted. So that is the final answer here. That is the final answer. And of course, A minus combines with H, so you regenerate your catalyst. So what you started with. But this is the product here that we care about. This is the final answer. And I'm sorry, there should be a connection here, just like that. So if you look at our reaction over here, that's exactly what we wanted. So, and that's how you solve these. Again, as you do as you do more and more of these, they'll become more apparent and they'll become a lot easier for you to do. So thanks again for watching. Stay tuned for the next video.